Section 3.3 really is a section on computing different kinds of averages for groups of numbers. And in this section, we're going to study 4 different kinds of averages. The one that you're probably most familiar with, mean, which is just kind of the arithmetic average, where you add up all the numbers and then divide by the total of numbers. I'll talk about that in a second. The other kinds of averages we're going to talk about are median, mode, and mid-range. And none of these are terribly hard to compute. So I'll talk about each and show an example of each. So the mean, which is given by the symbol, mathematical symbol, an x with a bar over it, I say mean, which is given by the symbol x bar, is the sum of the data divided by the number of data points. This is a really slick formula. This says the mean equals, and this symbol right here, this capital Greek sigma, means to sum the numbers. So this means to add up the numbers and then divided by the number of numbers. So this says the mean equals adding up all the data, or the sum of all the data divided by the number of all the pieces. So this is a fancy formula we don't really need to have memorized in that symbol. So here's an example. 5 people are waiting in line at a Jack-in-the-Box. At a Jack-in-the-Box drive-through, have the ages 27, 18, 48, 34, and 48. What is the mean age of this group? So I'm just going to add up the 4 ages, 27 plus 18 plus 48 plus 34 plus 48, and divide by the number of people that were waiting, which is 5. So the mean, you add up the numbers, divide by the number of numbers that you added up, in this case 5. I did this all on my calculator to get a mean of 35. For this same set of people waiting in line at the Jack-in-the-Box, I could ask you to find the median, and the median in a set of data is the middle number when the data is ordered, or when the numbers are ordered. So for this Jack-in-the-Box problem, the people waiting in line had the ages 27, 18, 48, 34, and 48. If I want you to find the median age of the customers waiting in line at this Jack-in-the-Box drive-thru, I need to put the numbers in order. So I did that down here. I took the 18, I wrote it first because it was the lowest, the 27 second, the 34 third, and each of the 48s fourth and fifth, or lasts. And then to find the median, I just need to find the middle number. The median's the middle number in a group of ordered data. To find the median from this list, the first thing I'm going to do is search for the middle number. And to do that, I'm going to cross out the first number and the last number. And then I'm going to look at the numbers that are left. I'm going to cross out the second number and the second from the last number. When I only have one number left, if I can get to that point, then that number is the median. So for this group of data, the median age of the people waiting in line at the Jack-in-the-Box was 34, while the mean age was 35. These would both be considered the average age of people waiting in the line. These are different kinds of averages. Usually when I say the word average, I think arithmetic average, I think the mean, but it wouldn't be wrong to say that the average age of people waiting in the line was 34. So if you were a politician and you're trying to grab for a number that kind of fits what you want it to fit, you might choose one of the values over another. So this is a best case scenario when I'm going to compute a mean. If I'm asked to find the mean, and I can just start canceling out, first and last, second and last, third from last, fourth and fourth from last. If I have one number left in the middle, when I do that canceling, that number is the mean. This only happens when there's an odd number of data points. Here there's 5 data points, and every time we're canceling out 2 at a time. So eventually I'm going to get down to 1 data point. Unfortunately, if I have an even number of data points, you're going to have to average to find the median. So here's an example of that. Find the median for this set of data, and there's 1, 2, 3, 4, 5, 6, 7, 8 data points. So in the Jack-in-the-Box example, there were 5 data points, which is an odd number. Then the median will just be the middle number. In this example, there are 8, I'll say data points, and 8 is an even number. There's going to, in some sense, there's going to be 2 middle numbers. I'm going to have to average the 2 middle numbers to find the median. So if I'm giving you a set of data and I want you to find the median, the data has to be listed from smallest to largest or largest to smallest. It has to be ordered. And I just gave you this data organized from smallest to largest, so we have to reorganize it. So to find the median from any set of data, regardless if it has an odd number or an even number of data points, you start off by crossing out the first and the last, and then the second, and then the second from the last, and then the third, and the third from the last. You're not allowed to cross out all the numbers. So if I would have crossed out the fourth and the fourth from last, I wouldn't have had any numbers left in the middle, and that wouldn't give me the median. Once you get down to the point where you either have 1 number left or 2 numbers left, you're done doing all the crossing out you can do. When you have 2 numbers left, you have to average those to get the median. So the median for this set of data, I'm going to take those 2 numbers and average them, and I average 2 numbers by adding the numbers up and dividing by the number of numbers. In this case, it's 2 numbers, and so the median for this set of data is going to be 6. So the median is either going to be the middle number, and it's going to be the middle number when there's an odd set of numbers listed from smallest to largest or largest to smallest. So since this data had 5 numbers, which is an odd number, the median's actually just going to be the middle number. This data had 8 numbers. 8's an even number. I'm going to have to average to find the median, because when I go to cross out, there's not going to be just 1 number left. There's going to be 2 numbers left in some sense. The third of the 4 averages that we're going to learn in this section is mode. And mode just means most in some sense. So up here it says the mode is the piece of data that occurs the most often. And for this Jack-in-the-Box problem, find the mode of the ages of the people at the Jack-in-the-Box drive-thru. If I look at the ages 27, 18, 48, 34, and 48, the most common age was 48. So the mode is going to be 48 because it occurs most often. If everybody's age was different, I'd say there was no mode. However, there's sometimes we'll take the time to write, when we're asked to find the mode, 2 or 3 modes. I'll talk about that in a second. So if there is more than one value that occurs most often, then we'll list both of them as the modes. I'll show that in a little bit. But mode just means most often. Best case scenario, if you're given a set of data, there's one individual number that occurs more than any of the other numbers, and that's going to be the mode. That's the case here. 48 is considered the mode because it occurs twice and all the other numbers occur once. If I give you this set of data and ask you to find the mode from it, I look for the numbers that occur most. I see 2 2s, 3 3s, 1 5, 3 7s, 1 9, and 1 12. If I'm asked to find the mode, the most times any number occurs is 3, and both the 3 and the 7 occur 3 times. Since both the 3 and the 7 occur 3 times, they're the mode. 2 wouldn't be considered the mode because it doesn't occur 3 times, it only occurs 2 times. And for a number to be the mode, it has to occur the most number of times. In this particular problem, if I was asked to find the mode, I would say the mode is 3 and 7. And if this is case, the data is going to be bimodal, meaning it has two modes. You can be trimodal, I guess quadmodal. For our class, we'll never be more than bimodal. And if you, again, if there's no numbers that occur, like if this was the data, if I had the data was 2, 2, 3, 3, 4, 4, 5, 5, 6, 7, 8. I guess I could say 1, 2, 3, and 4. I could say 2, 3, 4, and 5 are the mode. For our purposes, if we get beyond bimodal, we're just going to say there's no mode. So if we get two numbers that occur equally the same amount of times, and that's the most any number occurs, we'll call it a bimodal data, but I don't think we'll do trimodal or quadmodal, I guess this would be. So here's another example. Find the mode of this set of data, and since each of the numbers only occurs once, when we're going to find the mode, we're looking for the number that occurs the most. I'm just going to say this has no mode because each number occurs the same amount of times. But even on this last example that I wrote here, I would still say there's no mode. So if there's more than in some sense two modes, we're just going to say there's no mode. So far we've done mean, which basically is you sum up the data and you divide by the number of data points. We did the median, and the median is in some sense the middle. If there's an odd number of data points, it is the actual middle number. It's going to be in the data. If there's an even number of data points, you're going to have to average. And to do the median, then the data has to be listed. An example of an odd number of data points would be like if I asked you to find the median of this group of numbers, because there's 1, 2, 3, 4, 5, 6, 7 numbers, and 7's an odd number, the median would be the actual number from the data, because I'd find the median of this, I'd cross out the first and the last, the second and the second from the last, the third and the third from the last. The median for that data would be 7. If I gave data like this, that's an even number of data points. Here there's 1, 2, 3, 4, 5, 6, 7 data points. The median is the actual middle number. If you have an even number of data points like this, 1, 2, 3, 4, 5, 6 data points, you have to average to get the median. To find the median here, I'd cross out the first and the last, the second and the second from the last, and because there's an even number of data points, to find the median, I'm going to add up the numbers and add up the middle numbers and divide by 2. I take the average of those middle numbers, and the median there would be 6. And the third thing that we've done so far is mode. And mode means the most. For the median, the numbers have to be in order to find the median. For the mean, it doesn't matter if the numbers are in order. Similarly, for the mode, it doesn't matter if the numbers are in order. To find the mode, I'd look for the most, and in this data set right here, this is just a single mode of 5. So mean, add up the numbers, divide by the number, just your traditional average. Median, it's the middle number, and it may be a number in the data set, or you may have to average 2 numbers to get it, and mode is most. The last one we're going to do in this section is midrange, and midrange is adding up the lowest plus the highest number and then dividing by 2. So if I ask you for the jack-in-the-box data to find the mid-range of the data, the formula for finding the mid-range is taking the lowest number and the highest number and dividing by 2. For this jack-in-the-box problem, here's the ages. 18 is the lowest age, 48 is the highest age. To find the mid-range, you add up the lowest age plus the highest age and divide by 2. If I want to do this on my calculator, I'd just go 18 plus 48 in parentheses and divide by 2, and that would give me the mid-range is 33. All right, here's another skill that you're going to need to have in this section. So let me see what we can do here. Cindy's mean average on 7 exams is 80. Find the sum of her scores. This is inherently assuming that each of Cindy's tests were worth 100. No, I guess it doesn't assume that. Take that back. So to average 80 on 7 exams, if you want to find out the total number of points that she has, you would just take the number of tests times her average, and that would give me what the sum of her scores is. So the sum of Cindy's scores would be 560. This is because if I told you she scored 560 points on 7 tests to find her average grade, you'd go 560 divided by 7. So her average score would be the sum of her scores, which in this case is 560, divided by the number of tests that she's taken, and 560 divided by 7 is 80. So this is kind of going backwards it's kind of going backwards from computing an average. So if you know the 2 numbers that make up the average, 2 of the 3 numbers that make up the average, you can find the third. So if I know the number of data points and I know the average, I can find the sum of the scores by dividing, because for this problem to solve, for the numerator of 560, we would just multiply both sides by 7. So this is an important skill to know for test type questions. We're going to do some test type questions. And the classic test type question we're going to do is exactly this. So it says a mean average of 90 or greater is needed on 5 exams to get a final grade of an A. Thurston's first 4 exam grades were 83, 85, 95, and 90. What grade does Thurston need to get on the 4th exam to get an A for the course? Super easy to figure this out, because I just need to know 2 things. I need to know how many points Thurston needs for an A and how many points he has now. And the difference between the number of points needed for an A and Thurston's current total points will tell me how many points he needs. So Thurston needs to average 90 on 5 exams. So how many total points is he going to need? The total points needed are 90 times 5, which is 450. That's just what the last example helped us figure out how to do. So he needs 450 points. Thurston has 93 plus 85 plus 95 plus 90. I'll try to do that in my head. So Thurston has 363 points. The difference between the total number of points he needs, 450, and the total number of points he has, 363, that's what he's going to need to get on that 6th test to get an average of an A. So the difference between 450 and 363 are 87 points. That's going to be what Thurston's going to need to get on the 5th exam to get an A. So as I worked this out on this sheet, this is exactly what I did here. I said Thurston needs 90 times 5, or 450 points for an A, because you need to average 90 on 5 exams. I added up Thurston's points and got 363 total points. The difference between what he needs and what he has is the total number of points needed to get the A. For this same example, I did another question. It says an average of 80 is needed to get a B. What grade does Thurston need to get a B? Simple to do that. First I'm going to figure out the points needed for a B. We're taking 5 tests after we're done with all the tests. I need to average 80 on each, and 5 times 80 is 400. So you need to have 400. Thurston has, and when I added up all the test scores, he had 363 points. And the difference between what you need and what you have are going to be what you need to get on that last test. In this case, I think that's 37. So he's going to need 37 on the 5th test. To get a B. The only little, whoops, oh, I think that's a mistake there. Let me make sure. Thurston has, 363 points. So, when I added this up here, this should be 93, this should be 363. This work is correct. The work I have typed up for some reason isn't correct, which is kind of disturbing. So those are easy to figure out how many points you need for a specific grade. If I tell you exactly the average that you need, is not so hard. The trick to this kind of problem is what would happen if we do this? What would happen if I drop the lowest grade and still want to get a specific grade? So part C says, what if his lowest grade is dropped? So for Thurston, his grades were 93, 85, 95, and 90. Let's assume that we're going to drop the 85. So we're only going to keep the 93, the 95, and the 90. And then we're asking, what does he have to get on that 5th exam to get an A? This is a little bit different because when I go to figure out the total points needed for an A, it's not going to be 450. When we initially figured out how many points Thurston needed for an A, I said I needed to average 90 on 5 exams or get 450 points to get an A. If I'm dropping the lowest test, then the total points needed for an A aren't going to be 450. The total needed for an A in this scenario, I need to average 90, but I only need to take my best 4 tests. So I need to average 90 on 4 tests. So I need 360 points for an A. And then again, the difference between the total points that you're keeping and the total points that you need are going to be what you're going to need to get your A. And for this situation where we drop that low score, then I have to drop it from Thurston's total. And so now Thurston needs to do an average of 90 on his best 4 tests or get 360 points to get an A. So far, his best 3 tests are 278 points. The difference between the 360 that you need to get on your best 4 tests and the 278 that he has so far in his best 3 tests are going to tell me what he's going to need to get on that last test. So Thurston's going to need 82 to get an A as opposed to the 87. So that's all the examples I want to do. Now we just need to do some homework, and I'll probably just do most of my homework because this is pretty easy. So for each of the problems between 1 and 8, we're asked to find the mean, the median, the mode, and the mid-range. I usually do the median last if my data is given in a nice order because I destroy the data when I find the median. So when I look at my problem, it has 7 pieces of information. 7's an odd number. The median's going to be one of the numbers. When I look at yours, you have 6 pieces of data. Your median's you're going to have to average to find it. I'll do problem 2 right now. I'm going to find the mean To do the mean, you're going to add up all the numbers. So in my case, 1 plus 2 plus 3 plus 5 plus 6 plus 6 plus 7. And I'm going to divide by 1, 2, 3, 4, 5. I'm going to divide by 7 because there's 7 data points. First, I'm going to add up the numbers 1 plus 2 plus 3 plus 5 plus 6 plus 6 plus 7. And I get 31. And I'm going to divide by 7. And it doesn't say anything about averaging. I'm going to default to average to 2 decimals. So for my answer, I'm going to say the mean is 4.43. I could have said the mean is 31 over 7. Would have been more exact, but in general, I'm going to take any decimal and round it to 2 decimals. Hopefully I have your answers. I don't know if I do. Yeah, I do. And I'm going to do the mode next because the mode is easier. It doesn't destroy the data so much. I look at my data. There's 2 6s, and every other number is only listed once, so the mode is just the number 6. The mid-range is the low plus the high over 2. So for my mid-range, the low is 1, the high is 7. My mid-range is going to be 1 plus 7 over 2. That's going to be 8 over 2, which is going to be 4. And now I'll find my median. I'll cross out the first and the last, the second and the second from the last, the third and the third from the last. The number that's left is the median. Your median's also going to be 5, but you'll get it differently. So for number 1, your mean is 7, your median is 5, your mode is 5, and your mid-range is 11. I'll just do 3 with you. So in order to do 3, if I want to find the mean, I don't have to reorganize the data. So to do the mean, I'm going to go 11 plus 13 plus 15 plus 12 plus 18 plus 5 plus 1 plus 13. And I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8. I'm going to find the numerator first by going 11 plus 13 plus 15 plus 12 plus 18 plus 5 plus 1 plus 13. And I get 88. So this is going to be 88 divided by 8. And that's going to give me 11. So part of my answer is the mean's going to be 11. Since the data is not organized from smallest to largest, I'm going to find the median by organizing the data, taking it one piece at a time. So the smallest number is 1, I'm going to write it first. The second smallest is 5, I'm going to write it second. The third smallest is 11, I'm going to write it third. Fourth smallest is 12. Fifth smallest is 13s, and I have 2 of them, so I'm going to write both 13s down. Sixth smallest is 15, and the largest is 18. So I've written all 8 pieces of data, 1, 2, 3, 4, 5, 6, 7, 8 pieces of data down. And now I'm going to find the mean by crossing out first and the last, second and second from the last, third and third from the last, and I'm left with 2 numbers in the middle. I'm going to find the average of those 2 numbers by adding them up and dividing by 2. So I'm going to add up this 12 and 13 and divide by 2. This is going to give me 25 over 2, which is 12.5. So the second piece in my answer is the median is 12.5. The third number I'm going to put in my answer is the mode, and the mode is the number that occurs the most. There's only one number that occurs more than one time, that's the 13. So the mode is going to be the 13 because it occurs the most. And lastly, I need the mid-range. To find the mid-range, it's the low plus the high. The lowest number is 1, the highest number is 18, and then divide it by 2. This is going to be 19 over 2, I think that comes out to 9.5. I can do that without my calculator. So if I haven't made any math errors, those are the answers for problem 3. I'll check real quickly because I have the set of answers here. I see mean 11, median 12.5, mode 13, mid-range 9.5. All right, so give 5 a go. I'll do 6 real quickly. My mean for number 6, I'm going to go 2 plus 2 plus 4 plus 5 plus 5 plus 6. I'm going to divide by 6. This is going to give me 24 over 6, which is 4. That's going to be part of my answer. I'm going to hold off on the mode. Well, I'm going to do the mode next because mode is most, and for my most, I'm going to get 5. You, for your most, you're going to get bimodal 1 and 5 because they both occur 3 times. I'm holding off on my median because it destroys the data. For mid-range, since my data is ordered from smallest to largest, it's easy to see the smallest, it's easy to see the largest. The mid-range is the smallest plus the largest, mine 2 plus 6 over 2. This is going to be 8 over 2, which is 4. And then the last number I need is the median. So I cancel out the first and the last, the second and the second from the last. I'm left with 2 numbers. I'm going to average those 2 numbers. Get 4 plus 5 over 2, which is 9 over 2, which is 4.5. So here's all the answers for mine. The median is 4, the mode is 5, mid-range is 4, median is 4.5. For your problem 5, I've got the median and the mean at 3, bimodal 1 and 5, and I got the mid-range at 3 as well. I'll let you do 7. I won't even do 8. I think you're probably getting tired of watching me do this, so this shouldn't take that long to do. Just in case you want to check your answers, it says round the mean to 2 decimals. For number 7, I come up with a mean of 4.86, a median of 4, a mode. I'd said there was no mode because there's no number that occurred more than once. They all occurred once. I just call that no mode. And it gave me, for number 7, the mid-range is 5. All right, 9 and 10 are super easy. So for number 9, Peter's mean average on 6 exams is 74. Find the sum of his scores. The sum of Peter's scores are the number of times he's had that number of tests he's taken times his average. The answer to the sum of Peter's scores is just going to be whatever 6 times 74 is, and that's 444. That's going to be my answer to number 10. If we knew Peter's tests, they'd add up to 444. For your number 9, it's going to be 405. A very Brady Bunch set of questions. So I won't do 12. I'll let you do number 11. Jan's mean average on 4 exams is 90. Find the sum of her scores. She has 4 scores, an average of 90 each. 4 times 90 or 360 is going to be the sum of her scores. I'll do 13 with you because it's a little bit different, but it's the same idea. So Lamont plays high school basketball. After 20 games, Lamont averaged 18.5 points per game. This is from Sanford & Son. Obviously, I was thinking about 70 sitcoms. Grady as well from Sanford & Son, if you even know the show. How many points did he score? It's the same idea. You take the average times the number of times that it took to get that average to get the sum. So Lamont averaged 18.5 points per game times 20 games. If you multiply the average times the number of times it took to give you that average, that will give you the sum of the data. So the 18.5 points per game times the 20 games gives you the 370 points that Lamont scored in those 20 games. I don't know why I did so many of these, but I did. A new sub shop sells 70 70 sandwiches each day on average. How many sandwiches do they sell in a week? Hopefully you could do that very quickly, because it's the average times the number of times it took to get that average. The average was 70. They did that in 7 days. The total number of sandwiches they would sell in a week is 490. That's your 15. All right, I'll do 17 with you. Hopefully just pause the video and do it yourself. We've done something like this already in the example, so maybe you can do it. All right, mean average of 80 or greater is needed on 5 exams to get a B. Thurston's first 4 scores are 73, 69, 85, and 80. Part A, what does Thurston need to get on the 5th exam to get a B? So I need to know the total needed for a B and the total he has. So for Thurston, the total needed for a B, he needs to average 80 on 5 exams. He needs 400 total points on his 5 exams to get a B. And I also need to know the total that he has. He has 73 plus 69 plus 85 plus 80. Which is 307 points. The difference between what he needs to end up with in terms of total points and what he has in total points gives me the answer to part A. Thurston's going to need 93 on that 5th exam to get an A. If I move down to part B, an average of 70 is needed to pass the course. What grade does Thurston need to get a pass? So I need to find the total points needed. In this case, I need to, on 5 tests, average 70. So I'm going to take the average of 70 times the number of times I need to average that. That's going to be 350 points needed to get a passing grade. And I know that he has 307 points so far. The difference between the 350 points he needs to pass and the 307 points that he has gives me the total number of points he's going to need to pass, and I come out with 43 for that. Last part, what if his lowest grade is dropped? Well, if his lowest grade is dropped, then everything changes. So what is he going to need? Well, he needs to pass the class, so he needs to average 70, but now we're only keeping the best 4 exams, so we're going to take the 70 that's needed to pass the class times the number of exams that we're going to count towards your final grade, which is 4. So in this case, Thurston's going to need 280 points to pass the class. This is Thurston from Gilligan's Island. I can tell that I'm old and I was bored when I was writing these. And in terms of how many points he has, I'm going to get rid of the 69. I'm only going to keep the 73, the 85, and the 80. And when I add up the points that he's keeping of his best scores, we're keeping 238 points. The difference between what he needs to get from his best 4 exams and what he has so far in his best 3 exams is what he's going to need to get on that last exam, which is 42. So the answer to part C, if we drop the lowest test, you just need to get a 42. This is because the lowest test is 1 point under a passing grade, so it saves you 1 point in some sense. So 19 might be hard because it's a trick. And so I'm going to go through 20, and I'll flash 19 back up here in a second, because So far, all the tests that we've done have been weighted the same. So a mean average of 70 on 6 exams is needed to pass a course. On her first 5 exams, Ellie, Beverly Hillbillies, received grades of 55, 77, 62, 64, and 95. The first 5 exams are worth 100 points, and the last exam is worth 200 points. What grade must she receive on her last exam to pass the course? So in this class right here, the total points possible, I need to know the total points possible real quickly for this class. The total points possible are the 5 exams at 100 points, which is 500 points, plus the 200 point for the last test. So there's going to be 700 points possible. And she needs to average 70 to pass the course. So total needed to pass is the 70%. Oh, that's even trickier. Sorry about that. She needs to get an average of 70 out of the 700 points. I need to change that average to a percent and then to a decimal. She needs to average 70%, which is 0.70, of the 700 points to figure out what she's going to have to get to pass. She has to average a 70, which is an average of a 70%. And out of 400 points, to average 70 or 70%, you need 490 of them. Because if you did 490 out of 700 points, you'd get 0.7 for your grade, which is 70%. So she needs 490 points to pass. She has 55 plus 77 plus 72 plus 64 plus 95. You can tell that I'm a bit rusty. I don't do this problem on the tests normally, and meaning I haven't thought about it since the last time I lectured, and that's these videos I'm replacing videos that are about 3 or 4 years old, and that's why the rust here. So the totals she's going to need to pass this class under this scenario is the difference between the 490 needed for a C, or passing grade, whatever that happens to be, and the 363 she has. And for that 200 point test, she's going to need to get 127 on it. So the answer to part A of number 20 is she's going to need 127 points to pass the class. I have a part B. It says an average of 80 is needed to get a B. Is it still possible for Ellie to get a B? Well, to get a B, I need to figure out how many points she needs to get a B. And the points needed to get a B is going to be 80% of 700. So when I go to do this, I need to figure out the total number of points needed for a B. She needs to average an 80 or an 80% of the 700 points possible. So Ellie needs to get 80%, which is 0.80 as a decimal, times the 700 points that are going to be possible in this class, the 5 100 point tests and the single 200 point test. She's going to need 560 points to get a B, and she has 363 points. The total that she has, if it's within 200 points of what she needs, she can get a B. And she needs 560 total points. She has 363 total points. It's going to be possible for her to get a B because the difference between what she has and what she needs is less than the 200 points that the test is worth. So yes, it's possible for her to get a B. If so, which grade would she need to get? She needs to get 197 out of 200 to pick up her B. So So your problem 19 is exactly this kind of question. I'll let you read it. I'll write the answers down so you can check yourself. The answer to part A I came up with was 173. The answer to part B I came up with is 113. So give it a go, and hopefully this was adequate. If you weren't happy with the video, or if you aren't happy with anything that I do, you can tell me. I can redo anything. I'm on my Christmas break trying to get done with all the videos just because they were feeling so old that I just felt the need to update them.